Okay, hey guys, so today we're going to be learning how to implement the insert function in our singly linked list. And the basic thought is that if I have this list right here and I call the insert function, I want to be able to pass the previous node that's going to be before um, the new node that we're adding, and the data for the new node that we're adding itself. So if I'm calling the insert method and say I want to pass this, I want the new node to hold the data of new, and maybe I want it to be after our head. If we call this function, our resulting list should look something like this, where uh, there is a new node after our head list, after our self.head, that consists of the new data that we passed as a parameter, and after that is just the rest of the list like it was before, after the head element in our previous list. So I think this is pretty self-explanatory. You just want to add a new node and specify where this node is going to go by telling what the previous node is going to be. And so let's start typing it, and make sure, if you guys want, try it to do it yourself the first time, because that's the way you're going to learn the best. But if you're having a little trouble, definitely come back and we'll work through it together. And so hopefully you've done that right now. So why don't we get started? The first thing we're going to have to do, much like a lot of these other earlier methods that we wrote, is we're going to have to create our new node. And so we'll just say, once again, new node is equal to node data. And so this is going to create the new node that we're going to insert. And now what we're going to do is we're going to loop through our singly linked list to get to a point where we land on our previous node. And so what we're going to do, we're going to say cur is equal to self.head, so that we start at the beginning of the list. Then what we're going to say is while cur, and cur is not equal to the previous node, we want to go to the next node. So what this is going to do is we'll do this self.next. So this is basically referencing the this node that holds the data value of b, and what we're going to want to do is we're going to want to add a new node with the data value of new after this, right? And so what we're doing in these two lines of code is that we're starting off at the head, and we're saying while there's a node at that current position and that node is not equal to the previous node that we specified. So in this case, the node holds a data value of a, which is not the self.head.next, it's the self.head itself. We want to move on to the next node. And so we go from this node to the node that holds the data value of b. And so in this case, there is a cur, but the cur is equal to the previous node, the prev node that we specified in a parameter. So we're going to break out of the while loop, and we're going to start inserting our new node right here. And so this is just a little basic example. If we want to insert something here, if we want to insert something after this node, we'd have to specify that, and through these two lines of code, we'd just keep looping through until either we get to the end of the list, or we get to the node where the current node is equal to the previous node that we specified. And so hopefully that makes a little sense. And so once we get to that specific node, which in this case is going to be the b value, since we want to add after the sll.head.next, that's the node that holds the data value of b. Once we get here, we want to reroute this arrow right here so that it, oh sorry, let me redo this. We want to redirect this arrow here so that it's not pointing to the C, but it's pointing to the new node with that data value of new that we passed in. And so how are we going to do that? We're just going to say that since we're on the cur node, we're going to say that Well, actually, before we do that, we're going to make sure that we have the correct node. And so if we do get to the end of the list and cur is none, well, we're just going to handle for that real quick. We're just going to say if not cur, which means cur is equal to none. If that's the case, we're just going to return. And so now once we've handled for that, what we're going to say here is we have this, we've landed on this node, right? We want to direct this arrow to the new node, but the thing is you also want to keep track of the node of this C node so that you can redirect our new node to point at that C node as well. And so what we're going to do, we're going to make a variable called next, and we're going to make that equal to cur.next. And so what that's going to do is when we make this next variable, we're saying, since we're on this node as of right now, we're saying that we're going to look at what the next node is, which in this case is C, and we're going to save that next node in this variable right here. And then what we're going to say cur.next. This is where we're going to redirect this arrow. We're going to say cur.next. This b value, the next value, is going to point at the new node. We're going to say cur.next is equal to the new node. And so this is going to redirect the arrow to, instead of pointing at the C node, it's going to point at the new node. And then what we're going to do is now that we've redirected this arrow, we want to make sure, as of right now, this new node is pointing to none, right? Because that's how our nodes are set up. The next value is pointing to none. So we want to override that, and we want to say that this new node should be pointing at this C node that we saved earlier in next. And so all we're going to say is the new node dot next is equal to that next node that we stored right here. And so once we've done all that, we've inserted our node right where we want it, and let's just test this out to make sure. And so before I do all that, let me clear all this. Let me run. So right now we've appended appended nodes for A, B, C, D, and E, and so we print them out right here. If we run this code, the goal is, like I was saying before, you want the new node to go after the B, and that new node to point to C. And so if we run this, that should work, and it does not. Let's see. A, B, C, D. Next equals cur.next. Cur.next equals new node. New node.next is equal to. Oh, I forgot to save it. So make sure to save your code because I just forgot to do that. If we run that again, now we see our new node is placed after the B. And so let's just go through a quick summary of what we did. We created our new node, right? We stored our head so that we can loop through every node. And we're saying while there's a current node, and that current node is not equal to the previous node that we passed in as a parameter, we're just going to loop through all the nodes until we get there. So either we get to our previous node, or we get to none. If we do get to none, we're just going to return right there because that means the previous node that was specified, it doesn't exist. But if there is a value in current node and that current node is equal to the previous node, we're storing the next value. We're storing that C value, right? The C node. We're saying that our B node, our current node, our previous node, the next value is going to be equal to that new node that we created earlier. And then we're just going to say the next value for the new node is going to be equal to the cur.next, or the next variable that we stored earlier. So we're just redirecting our arrows so that this B is pointing at the new, and then our new node is pointing at the C. And once we've done that, that's going to be the end of our insert function, and that worked just the way it should have. And so hope to see you guys in the next video, and Make sure you guys practice this and try to do it on your own because that's when you learn the best. All right, see you guys next time.